This is a recording for section 11.1, the fundamental counting principle. We use this actually in graph theory to find the number of Hamilton circuits on n vertices. But here we will use it in the context of probability. If you can choose one item from a group of m items and the second item from a group of n items, then the total number of two choice items is m times n. Example, if Bob has 3 shirts and 2 pairs of pants, how many different outfits can he make? Part A, use the listing method, and B, use the fundamental counting principle. So he has 3 shirts. We'll just call them shirt 1, shirt 2, and shirt 3. And 2 pairs of pants, pant 1, pant 2. So we want to know all the possible combinations. So we will, or the total number of outfits using the listing method. So we'll start with shirt 1. Shirt 1 could go with pant 1, or shirt 1 could go with pants 2. Next, we will go to shirt 2, and shirt 2 can go with pants 1, or shirt 2 could go with pants 2. And lastly, shirt 3 could go with pant 1, and shirt 3 could go with pant 2. So you can see that there's 1, 2, 3, 4, 5, 6 possible outfits. All right, but you can imagine that if you had 10 pairs of pants and 15 shirts, you certainly wouldn't want to list them all out. All right, so instead you would use the fundamental counting principle, which if there's 3 shirts and 2 pairs of pants, you multiply them out to get 6 outfits, which is exactly what we got when we used the listing method. Next semester, you are planning on taking 3 courses, Math, English, and Humanities. There are 8 sections of Math, 5 sections of English, and 4 sections of Humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? So it's 8 sections of Math times 5 sections of English times 4 sections of Humanities. 20 times 8 should give you 160 possible schedules. All right, and this would be one we certainly wouldn't want to use the listing method, right, because we would not want to do Math 1 with English 1 and then do that with 8 Math, 5 English, and 4 Humanities. Question 3, you are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct per question. If you select one of these 4 choices for each question and leave nothing blank, how many ways can you answer the questions? Well, it has 10 questions, so you can answer the first one in 4 ways, the second one in 4 ways, the third one. So you would have to multiply 4 together 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And another way of writing 4 multiplied 10 times is 4 to the 10th power, which you can certainly multiply 4 together 10 times and get an answer. But let's try to locate the exponent button on the calculator. If you have the calculator that I've recommended on the syllabus, TI-30X11S, you will see that it is the 1, 2, 3, 4, the 5th button down in the left column that looks like this. So if you want 4 to the 10th, you do 4 to the 10th and then press the enter. So let's do that, 4 to the 10th, and you would get, looks like 1,048,576 different ways that you could answer. All right, just like AA, all A's. You think about how many ways there are. 10 questions, you can answer them all A's except for the second one, a B, etc. All right, so there's actually over 1 million ways of doing that. If you don't have the TI-30X11S, I would highly recommend getting one for this class, but if you cannot, they are somewhere around $10. You can also look on your calculator for a button that looks like y to the x. So you hit 4 and then your y to the x, which will raise it to the 10th power, and you can press equals. Those are about the only two buttons I see, is that y to the x and then this caret here. And the last example in section 11.1, telephone numbers in the United States begin with a three-digit area code followed by a 7-digit local telephone number. Area codes and local telephone numbers cannot begin with a 0 or 1. How many different telephone numbers are possible? So you can think that there's a 3-digit area code, right? And then there's a 7-digit, a 7-digit number after that. So with the first digit, right, it can't be 0 or 1, right? So if you think about it, you could only get 2, 3, 4, 5, 6, 7, 8, 9. That's 8 possibilities, right? The digits 0 through 9, that's 10 numbers, right? But you can't have 0 or 1. So there's only 8 possibilities. But the second number can be any number, 0 through 9. So there's actually 10 possibilities there, 10 possible digits here. Again, the 7-digit number cannot begin with a 0 or a 1. And you just know that anyway from phone numbers. Nobody starts with 0. So there's 8 possibilities there. But then you could have any of the 10 digits after that. So you can certainly multiply those all together. You can multiply the 8s together to get 64. 1, 2, 3, 4, 5, 6, 7, 8. And then you can times that by 10 to the 8th power. So you would just do 10 to the 8th. And then 10 to the 8th and hit equal, and then multiply that by 64. And if you, this is, of course, scientific notation. Your calculator might give you 64 and then have 8 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8. So you can see there's actually 6,400,000,000 ways of different phone numbers. But if your calculator gives it to you in scientific notation, just remember, like it would probably give you 6.4 times 10 to the 9th maybe. My calculator actually gave it to me in standard form. So it gave it to me like this. But if it does give it to you like this, remember that the exponent just tells you how many places you move the decimal over. So you'd have to move the decimal over 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you'd have to put in 8 zeros, okay, if your calculator gives you that notation. But mine actually gave me this. All right, that is the end of section 11.1.